Namaste. How are you all doing? Hope everyone is good. So today we are looking at an article from World Economic Forum um, about quantum computer revolution uh, here tomorrow. So we must prepare today. Yeah. All right. So this is talking about the quantum revolution. Uh, so let's see. And this is the a component of Google's quantum computing setup. So they are mentioning it as revolutionary, not evolutionary, right? So let's read it out. The impact of quantum computing on internet security will be so great, we must start planning now. So its exponentially higher processing power will render widely used cryptography obsolete. So currently, like the cryptography is based on the mathematics, the algorithms which are like which takes like huge time to crack with the classical computers. But with the quantum computing, but with the quantum computers, with the availability of the quantum computing, that will take very less time, and those are very vulnerable, like the current cryptographic systems. Uh, so security, agility, crypto agility is a key concept in being quantum ready. Yeah. So they kind of like copied a channel name, I guess. Okay, cool. Anyways, strategic thinking has enabled many of mankind's great success, but when some leaps are just too big for a single bound or too far into futures, strategic acting, incremental, consistent decision making, consistent with long-term vision, can serve as an enabler for future success. Okay. So while an operationally viable quantum computer seems beyond the horizon to most, the steps needed to prepare for its inevitability or indeed within the sight. So we need advanced planning in cyberspace to prepare for the quantum computing impact, where without some changes, it will undercut all internet integrity and confidentiality. Yeah, so with the classical computers also, without like the quantum technology, we are hearing news of major companies being affected with these attacks, cyber attacks. So imagine the situation if the quantum thing developed. So this is a need of the heart. Um, yeah, the economic and social disaster. This is where strategy acting can come into its own. So, a quantum computer is radically disruptive. It will use a different method to represent and compute information, allowing much faster speeds. It's not just evolutionary, it is revolutionary. Quantum computers will be as revolutionary in this century as computers were to last century's mechanical calculators. That will be a huge shift. They'll be built by essentially leveraging the properties of atoms. So kind of like the physics. Um, so physics versus kind of like math something, that sort of debate. So they will be millions of times faster. All right. A quick primer on internet security foundations might help us understand this disruptive potential. So the foundations include like the confidentiality, integrity, and authentication of the people, machine, software, data, and that underpin all internet security. Um, Cryptography, the use of mathematical equations to protect information that is in their foundation, right? Is at their foundation. So confidentiality, scrambling data to render it private. Um, so integrity, preventing attempts to like falsely change the number like values or anything of such sort. And authentication is verifying the identity of the user you're communicating with or you're using with. So how does something as important as cryptography work? So this is more detail into the cryptography, like not more detail, but kind of like a basic perspective to cryptography. So A good analogy is a combination lock on a high school locker. Okay. In this analogy, the padlock is a cryptographic algorithm and the secret numbers of cryptographic key. Okay. So combination locks have two security function: lock, which is a simple thing that requires you to do nothing more than kind of like push it to close the lock and secure it. Unlock a relatively complex mechanism that relies on secret numbers provided to the lock through a counter clockwise or counterclockwise motion. So that's what well designed and implemented cryptography is. Mechanism to easily apply the security, but completely impractical to guess unless you know the key to unlock it. But once an operationally viable quantum computer is produced, it can guess the possibilities at a substantially faster rate, exponentially. So if you try to read a cryptographically scrambled message by guessing the cryptographic key with today's fastest computers, even working together, it is not practical. Yeah. So the mathematics of cryptography trump over computer science. Crypt analysts may try to use supercomputers, but it's completely impractical to brute force a model crypto algorithms key, which is why cryptography serves as a foundation of security. So when I was like kind of introduced to this cryptographic and all, like I used to think like why can't I guess it? I can still make guesses, right? But what these mathematical algorithms um, in crypto key in crypto key make sure is it takes like so much long time to kind of brute force it, and they also have kind of like rules, right? So imagine an iPhone. So maybe if you can't unlock it in 10 tries, then it will like freeze or something. That's such that sort of thing. It will alarm you, or it will alarm the um, or it will alarm the authorities or something of such sort. So it's complex, and it's almost impractical to deal to crack that code using these traditional classic computers, right? So for decades, engineers made computers with more computational power by either speeding up the time it takes a processor to evaluate each individual binary possibility, that is 0 or 1, or adding multiple processors that look into parallel at different possibilities. In theory, with enough speed and parallel processing, you could test all possible lock combinations. But manufacturing complexities create a practical limit to the first approach. And the second technique, the parallel processing, becomes prohibitive due to processor cost and the expense to power and cool them. They melt or otherwise malfunction when running fast in close proximity. Therefore, well designed and implemented cryptography is far beyond the reach of fast parallel processor computers' ability to guess each possibility. Okay. But quantum computers can make many more guesses at once, sometimes resulting in exponential, the doubling of an amount, etc., and increase in processing power rather than incremental increases possible with traditional computers. Okay. Mm-hmm. And they are saying importantly, certain kinds of mathematical problems are well suited for a quantum quantum computer. Oh, okay. So most believe an operationally viable quantum computer, one that is most both reliable and has a useful number of qubits, is 5 to 15 years away, and that a handful of countries are pursuing that goal. We need to prepare now, right? Okay, this is how see this. Make the security agility part of your operational security doctrine when purchasing cyber security in the next 2 to 5 years. Tell your providers you want crypto agility, that is the seamless ability to swap to quantum resistant asymmetric cryptographic algorithms when available. Mhm. Okay, and adapt quantum resistance cryptographic algorithms when available. Okay, so this should be resistant to quantum technology. Ideally, use a standard quantum resistant algorithm several years before a quantum computer is thought to be available because uncertainty. Um, Quantum computer availability is unknown. The most advanced research on them is classified. Yeah, it's still in research phase. In interoperability, there needs to be a seamless transition to this new class of cryptography. There will be a time where crypto agility, the ability to secure and agilely choose and use different types of cryptography, will, will enable communication with both those who use quantum resistant cryptography and those who don't yet. Okay, let's read it again. There needs to be a seamless transition to this new class of cryptography. Yeah, there will be a time where crypto agility, the ability to securely and agilely choose and use different types of cryptography, will enable communication with both those who use quantum resistant technology, cryptography technology, and those who don't yet. Yeah, there must be a seamless kind of like transmission. That's what they're saying. Okay. Inventory your data assets to see which ones need to be re-encrypted with a quantum resistant cryptographic algorithm. Some data is so valuable that it has a long shelf life and must be protected from those adver- adversaries who steal your encrypted data now and break it with quantum computers available in the future. So, awareness and education, tell your colleagues what it's all about and why they should care, making a distinction between three main topics: quantum computing, much faster computers, quantum resistant cryptography, algorithms that need to be developed and adapted to prepare for the eventual computers, quantum key exchange. It means to privately share information while detecting when it has been compromised. All right, quantum computers will be revolutionary in their speed, so much so that they can undermine the foundation of internet security. They're not simply a technical curiosity to marvel at, but a revolution that requires us to plan for their arrival ahead of time since they can undermine internet security. We should adapt agile, integrated cybersecurity strategies now, including agile cryptography to ensure we are prepared for the age of quantum computers. Will usher in. Okay. So this is by phil-quade, Chief Information Security Officer, Fortinet. Yeah, yeah. Thank you, sir, for this wonderful article. Okay, guys. Bye for now, and I'll see you in the next video. Take care.